Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Forcing by Koktuslav, and here are the rules. We need to divide the grid into 9 non-overlapping regions, each consisting of 9 orthogonally connected cells. And this looks like it's a typical chaos construction rule set, where we need to place the digits 1 through 9 once each in every row, column, and region. So what is an orthogonally connected region? It just means you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region, because for every cell in the region, you can go to any other cell in the region just by going through edges while staying within the region. This is not valid as an orthogonally connected region because these two cells, even though they can connect to each other by going through edges while staying within the region, they cannot connect to the rest of the regions or rest of the cells in the region by going through edges while staying within the region. They have to either go through a corner or exit the region by going through edges, which is not allowed. So that's an example of how orthogonally connected regions work. In each region, place a circle in the leftmost cell of its topmost row. Every circled digit counts how many cells of its own region, including itself, are visible in its column. In its column specifically. So every region, in each region, place a circle in the topmost cell, in the leftmost cell of its topmost row. So in this region, the circle would have to be here, because the topmost row is here. The leftmost cell of the topmost row is this cell. And every circled digit counts how many cells of its own region, including itself, are visible in its column, and region borders block view. So in this case, it would be a 3. Say we did something funky. Can we do something funky? Yes, say we did something funky like this was the region. 1, 2, 3, 4, 5, 6, 7, 8, 9. This would still see 3 cells because region borders block view, and this is a region as a whole. The border would have to go here, and then it would only see these 3 cells. It would not see this cell here. If, however, we had this cell here as part of the region, then this would have to be 4 because it sees 4 cells, including itself, in the same column. The 9 circled cells together form an extra region. That is, they are orthogonally connected and contain the digits 1 through 9 once each. Huh. That is interesting. So that means if we were to have all 9 cells, they would all 9 circled cells, they would also have to form a sum. They would have to basically form another region itself that's orthogonally connected, which means you can go from any cell in the circled cells, to any other cell in the circled cells just by going through edges while staying within the region. And we have the digits 1 through 9 once each in these circled cells also. Interesting. So this is an easy chaos construction rule set, which I'm kind of skeptical of, but I can sort of see, I'm thinking about that specific rule set here. And I can sort of see it potentially being forcing, in that it forces a certain way that you can actually have those work. Huh. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so the circled cells. Okay, so there's a couple of things that are very restrictive here. One is in the circled cells, you have to have the digits 1 through 9. That means the 9 is saying how many of its cells are visible in its column. Well, the thing with that is, along with another restriction, all 9 regions have to basically be able to get to the upper left. So we have, obviously, the upper left corner is going to be the leftmost cell of the topmost, the leftmost cell of the topmost row of some region. So therefore, this is definitely going to be a circled cell. But we have all 9 regions have to be able to form an orthogonally connected region, right? And sorry, the leftmost cell of the topmost row of all 9 regions must be able to form an orthogonally connected region in itself. So the thing is, how is that going to work? Where is this cell going to have its topmost left cell in the the leftmost cell in the topmost row be orthogonally connected to that? It can only do so if this is the top leftmost cell of the topmost row. Okay, so it has to be on this diagonal. So you can go not 5 that way, 5 that way. Or you could go 6 this way, 4 that way. So it has to be somewhere on this diagonal is that it's going to be connected. And then this has to connect on this diagonal to this cell by doing the same thing. Well, this cell... And we have to have the digits 1 through 9. So it has to connect to this as circled digits, must connect to this diagonal as a region, orthogonally connected. And then from this orthogonally connected region, it must get to here. Obviously, it cannot go all the way here as a circle. If we try to go circles here, the problem is each digit in that circle would have to be 1, because there's only one cell in each of those regions, which are part of the region in the column. So it cannot go down to here. You have to have the digits 9 through 1. So you can't have similarly this way, right? Because if all the circles are here, they all must go just straight down. And then they would have to be all 9 to count the digits there. I'm thinking that it has to get to here, and then it has to get to here. But I could... Right, we have to have the digits 1 through 9. And they must count a full set. They must count how many digits in the columns add up to... So we have to have at least going to here. It cannot be any of these. Because if we have circle, circle, circle going to here, the problem is those digits are going to have to add up to 45, which means 45 of those cells must be accounted for in that same row. Right? It's saying how many digits are in the same region that it sees, and it cannot be, if it's just these 4 columns, that's only 36 cells that can be seen and that are in the same region, but it has to be add up to 45 for the digits in the circle, because they must be the digits 1 through 9. So it has to be at least going to here. It could be extending to here. That is potentially possible. It cannot go all the way up to here, though, because that would force this to be all 9s here, because this would be circle, 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 circle. They're all different regions. They must all go down. They have to continue going down as a region, so therefore that doesn't work. I'm guessing this is probably certain. Hmm. If we do something like that, that's problematic in that that would be 9 going that way. This would be 8, 7, 6, 5. Is that possible? That actually does kind of work. 3, 2, and 1. Huh. That actually does kind of work. So any of these 4 are potentially valid. Hmm. What happens if we do something like this? Oh, that doesn't work. That's too long. Oh no, that's fine. That could potentially work. Yeah, what happens if we do that? We could go the other way. Ew. So we have to try both ways. Hmm. How does that work? This must go down there. Then we have that. And it could go to there. This would then go that way. This has to go that way. And we have that. Okay, let's restrict only what we know. So we have, if this is the case, we have boundaries all along here. This can only go that way. This can only go that way. This can only go that way. This can only go that way, that way, that way, that way. So this must extend further. This must extend further. Extend further. Okay, so how does this work? We have light. This is green. This is red. We'll have yellow here. This is orange. We'll have pink, dark, medium. So medium must extend. Dark then has to extend. Pink must extend. Oh, this doesn't work. These would all be 1. So that doesn't work because that's 1. Right. Okay, so then what happens if we go the other path that way? Then we have something similar, right? This is the leftmost cell of the topmost row. So this has to go that way. That means none of these cells can be in the top row. So it has to go that way. This would have to go that way. But this would be 1. This would be 1. This would be 1. And this would be... This could be many things. But these would have to be 1, which does not work. So I think that's going to be the problem with anything that has anything above it, except for the first one, right? The first one can work fine. No, it can't because it has to be 9. So if this were here and here, this would have to be 1, and this would be 8, but there would be no 9 in the circles. So this cannot be connecting this way. So this can't be going to here because this would be 1. This would have to go here because there's no other circles, because you have to use all 9 circles to connect to one of these cells here so that they can connect to the bottom right as a region. So you can't go down because then none of these this is going to be, there's not going to be another circle in row 1, which means this would have to be 9 as the only possibility, but since this is blocked here by this circle, it can't be 9, which means there's no 9 in the circled cells, which we know there has to be. So therefore, this cannot go this way. It has to go this way. Huh. So this could go either of these ways, I think, actually, now that I think about it. Huh. Okay, well, this one we know has to be 9. Does it have to be 9? Probably, right? It either connects to here or here. We could have 1 here and 8 here. That is certainly possible. We could also have this being 8 and then continuing this way. So you could actually have circles going all the way here until this. How does that work, though? Say we did have that. Okay. The problem with this is this would have to go this way. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. This would be a 1, obviously. This would then have to go here, so this would be 8 going that way. So that is possible. But then these have to be straight lines, right? There's no other way they can break out. And then therefore these would all be 9. So it cannot do that. So can we go this way even before going here? I think the answer to that is probably no, right? Let's try. Then this would go... Yeah, because this is the leftmost cell of the topmost row, there is no... I mean... We have to orthogonally connect to this, one of these 4 cells. We showed that this doesn't work. And I don't think you can have more than 2. Right? If you have one on top, you can have one on top of another. You can't have one more be there, right? Because then that would force us to be 1 and 1 for digits seen in this column. So that's not going to work in that case. So you can't have 3 in a row. So it can only be one on top of another. And I don't think you can have another one. No, you can't. So I think you always have to get to here then. That's always going to be the case. So this is always going to be part of blue. I think this is guaranteed then. So you can't have one on top of another because the problem is these essentially become 1 in size. You're not going to be able to get, well, you might be able to get around this way. So the last one could go down. So it's one of these 2 then. Right? But I don't think you can go here. This obviously doesn't work because you have that pattern, right? And then these are all 1 because they can't see anything else in the column. Yeah, actually, this one doesn't even work either. Does it? 1, 2, 3, 4, 5, 6, 7, 8. If that's the case, it still doesn't see it. It's still 1. Yeah, you're always going to see 1. So you can only have 1 be on top of another, and that's the 1, right? Because you only see, you would be blocked by another region. So this has to be a circle, and it's blue. So the question is, where is that 1, right? So the one that's on top has to have a 1. We could drop there. We could drop any of these. We can't drop here. So if we go here, this has to go around here. And then these are all straight down. Oh. Yeah, if this is 8... So how does that work? So if we go here, I don't think that works. Right? Even if we drop down here, how does that work? This obviously has to be longer than this. This is 1. So this is 1 going that way. So none of these can be 1. So this must be at least 2. So we have 2 going there. Then 3 going here. Then 4 going here. 5. 6. 7. And this can't be 9 if this is not 9. So this would be 9, this would be 8, but then we'd be stuck here. So that's why this can't ever work, and you have the same problem if you try to go from here. So this must be the circles going that way. So we know this is not a circle. This has to be circle here. So these are all different regions. So we have region, 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 region. This must go that way. And that's done as a region for 9. This is the only one which can be 9, so that's done there. What's the one that can be 8? None of these can be 8 because that would block off these cells here. So if we have 8 here, that would force this to be a size of region of size 8. If we have here that we have 2 regions having a total of 16 cells when they need to be 18, etc., etc. So this is 9. We have 9. This is 8. That's 1. This is 7, 6, 5, 4, 3, and 2. So blue goes this way. This is, I don't know, orange. This will be dark, I guess. We'll have yellow here, pink here, medium here. This will be light. And we have green this way, and then red this way. So these are the regions. And this can't be 9 because of 9 in the column. So this is 1, that's 9. That means 9 has to be somewhere in blue, cannot be here, so this is 9 here. So 9 has to be somewhere in orange, cannot be here or here, so that's 9 here. 9 has to be somewhere in yellow, that makes all of these 9. We're missing a 1 in green, it has to be there. We're missing now a 1 in red, it has to be there, so then these are all 1. We're missing 2 in column 9, it can't be here, so it must be here. 2 can't be here in column in the orange region, so it must be there. Can't be here now, so therefore all of these are 2. And it's going to be 3 along the diagonals also. So where's 3 in column 8? It has to be here. Can't be here in yellow, so it must be here. Therefore, these are all 3s. And same thing, these are all 4s. Same thing, these are all 5s. Same thing, this is 6s. We have 7s, and these are 8. Remaining digit in red is 8. These are all 8 here. Remaining digit in medium gray is 7, so these are 7. This is 6. This is 5. This is 4, and we have 3 in the corner, of course. And that's the solution. Is this easy? I mean, it's really just the logic of the circles, right? I guess so. It does force a certain pattern. Yeah. I don't know. I'm not sure how I would consider this. Is it easy? It's probably one of the simpler chaos construction puzzles. I wasn't sure though how this would work, but yeah, I guess it kind of made sense once you thought about it, right? This could only see 1 if it goes this way, so it has to go across. Can't go 1 down because then there's never going to be a 9. And then you can't go multiple across here because then the problem is where is the 8 correspondingly, right? Um, I guess I could put this as easy. The logic behind it is basically just the logic of the circled cells. And that's fairly simple to come up with. And then the execution's very easy. So that's not too bad. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.